Good morning, students. Sayam. Good morning, students. सब आ गए हैं? Everybody has come?
No, ma'am.
Only 13 students from your class have joined at 10. Kindly be on time, otherwise I will not join you next time. And register with your proper name and your roll number, because this will mark your attendance in the lecture. If you are not registering with your name and roll number, you will not be marked. So wait for 2 minutes more that all the students join and will start the lecture. So the topics that we are going to cover today includes we'll study about network virtualization, as well as we'll study about storage virtualization also. And apart from that, we'll cover cloud computing architecture. What are the actors in cloud computing architecture and how this architecture is defined into various layers. And apart from that, we'll study about SLA, that is service level agreement. Only 20 students have joined, 22, 23. It's 10:03 now, 10:04. So before moving towards network virtualization, we'll discuss a little about a bit about what we have gone through. We did in the previous lectures. Uh, we were studying about virtualization in past two lectures, and we come across the concept called virtualization. And we know virtualization of compute devices. Compute devices, we mean the PCs. We are virtualizing the PCs. That means what we are doing is we are virtualizing everything related to a personal computer, whether it's network, storage, or any kind of resource, we can say. So we are virtualizing everything. But how, if we are talking about a single PC, it is okay. But whenever there are hundreds of PCs connected across a network, how we can virtualize the network concept, or we can virtualize the storage concept, that is of main concern here. So today we will study how this network virtualization will work, and as well as we'll study about the concept of storage virtualization. I'll show you the lab guide of Hawaii company. How this works in Hawaii company, and this cloud computing concept work in Hawaii company. How they work on virtualized environment, how virtual machines connect with each other through a network. I'll show you the lab guide here. I have a lab guide related to that. And we'll study about storage virtualization also. A little bit about storage virtualization. The concept of storage virtualization means if we have a hard disk here and we are virtualizing a single PC, then it is okay. But whenever we are dealing with virtual machines, how the hard disk will be divided among the various virtual machine, a particular hard disk of a particular computer, that physical machine is handling, or we can say that host is handling three virtual machines, how they are going to work, that is of concern here in the storage virtualization. So the basic topics that we are going to cover today will be network virtualization, storage virtualization, That will be a part of a little bit about storage virtualization, cloud computing architecture, the various sectors, the service providers, what are their duties and roles, and we'll talk about SLAs, service level agreements. What are those? We'll study that, and what are the various steps in SLAs. Or we can have a SLA between the consumer as well as between the service provider. So these things we are going to study today. I'm just waiting. Everybody should join, and we'll move towards the new topic. This new topic. So it's 10:07 here, and we are starting the topic. First of all, network virtualization. This is a basic diagram representing a virtual network here. You can see why I have shown you the diagram. This diagram covers the concept of virtualization, how various virtual machines are connected and they communicate with each other here. You can see there are three guest machines. From the guest machines, we mean these are the virtual machines, and they have guest operating system installed on it. We know how these machines are installed on a single machine. We know the procedure, how hypervisors are installed, and we have discussed these things, and we know what are hypervisor type 1 and what are the hypervisor type 2. So these are the three machines. So we can say these are three virtual machines, VMs, VM1, VM2, and VM3. And on these VM, we have guest operating system. We can have any guest operating system, but usually whenever we are virtualizing the physical hardware, we use the Linux operating system for making it a guest operating system. And these are some of the binaries or binaries and libraries here that form the part of the kernel that interact with the kernel of the particular uh, machine. Next is application program. Here one is application program is running here. One application program A is running here, and another application program A is running here. You can see here there are certain physical devices that are connected here. That is network address translation, NAT, and bridged kind of network here with the VM. And there is a virtual switch, and there is a virtual switch here, you can see. So this is shown here. This is the host machine. On this host machine, what we are doing is we are virtualizing the various virtual machines and their connection with the virtual switch. So we have created we can say a kind of virtual switch for connecting these guest machines with the physical hardware, or we can say the host machine. I think everybody is clear with the idea of host machine and guest machine. If anybody is not able to understand still the difference between a host machine and a guest machine, please raise hand. I'll again explain what is uh, the concept of host machine and guest machine. Yes, Sumit Kumar Jha. See, whenever we are talking about host machine, आप अभी किसी computer पे log in हो, you have logged into some computer, that is a physical machine, and that machine is called host machine. On that physical machine, if I have installed some kind of hypervisor to create three further virtual kind of PCs that are not existing, we are creating virtual PCs on those machines, that will be called as guest machine. So that is the difference between host machine and guest machine. आप अपने computer पे, अपने hardware पे, you have created three more computers, but there physically there is one computer, but you can have access to three operating system and three application that can run at the same time, and that concept is called virtualization. I hope Sumit Kumar Jha आपको clear हो गया हो. Next, on those guest machines, we are talking about the virtual machines, we have installed a different type of operating system, and those operating systems are called guest operating system. Why we are calling them as guest? Because they are only installed for various, for getting various services, for doing some kind of compute work. So that is why they are called guest operating system and guest machine. The host machine is shown here. You can see this is the host machine. So when there are three virtual machines and we want these three virtual machines should interact with each other, can exchange the data and information, or with the host machine, because they don't have any kind of we can say memory or any hard disk associated with it. These virtual machine will not have any hard disk associated with. ये तो एक सॉफ्टवेयर है, मतलब these are the software kind of things. They are using everything from this host machine. So that is the basic concept, and they are connected with each other using this virtual switching. So we can have a bridged or a network address translation NAT kind of approach, or we can have a virtual switch kind of approach. So when can we use a NAT or a bridges, and when can we use those um, virtual switches? Whenever we are using and doing some kind of small scale virtualization systems, like we are creating a single virtual machine on a physical machine, we are bound to physical NICs. That we know what is NICs, and a network interface card basically. And using the bridges or the network address translation, we can connect a physical machine with the single virtual machine, or two machines we can see. But when not a two machine, we can have a single machine. So in a large scale corporate virtualization system, VMs are connected to physical network using virtual switches. So whenever we are talking about large scale corporate virtualization, where there are hundreds of computers and there are hundreds of physical machines or thousands of virtual machines and hundreds of physical computers, we require some kind of virtualization switches. And those switches you can see on the screen here, these will be called as virtual switches. Here you can see a host machine handling two virtual machines using a virtual switch here. So this is a concept, basic concept here. But our network bridges, basically, a network bridge is not a new technology. We know what is a network bridge. You can use network bridges to enable network port to communicate with each other. Basically, the concept of bridge is to communicate with each other. Specifically, you can use network bridges to interconnect multiple networks ports, so that packets received on one network port will be replicated to others. So that if a particular packet is being received on one network port, that will be replicated to multiple network ports. So we can have a bridge in that case, and that can be used. Some people are waiting in the waiting room. I am not entering them in the waiting room because they people are late. This is the last time. Sonia, Sambhav Jain and Shivam Kapoor, kindly be on time in next lecture. Otherwise, I will not permit you in the class. So we were talking about the network bridge. So one port getting the information can communicate to multiple network ports, the packet received. So basically, in case of virtualization, the operating system is responsible for interconnecting all network ports. So you can see in the figure here, this is basically a bridged based interconnection in a Linux system. So you can see here, this is the NIC driver, and these are the two ports, Ethernet 0 and Ethernet 1, and this is a bridge 0. So this is the data queue. Data queue is giving any kind of information that is with the bridge, and which will see whether this will go here or will move here. So that is the basic concept. And here, after getting this information from the NIC driver, it can see whether it is coming from Ethernet 0 or Ethernet 1. This is a basic concept here. If the information is moving upward, it will be moving from the NIC driver to Ethernet 0 or Ethernet 1 both, and vice versa. Bridge 0 is bound to Ethernet 0 and Ethernet 1. We have seen that. The upper layer network protocol stack knows only the bridge 0. Upper layer protocol can only see this upper layer network can only see the bridge 0. They are not familiar with this Ethernet 0, Ethernet 1. And bridge 0 and does not need to know the bridging details. उसको नहीं है कि हमें पता चले क्या what are the bridging details, because the bridge is implemented at the data link layer. Whenever the upper layer network protocol stack needs to send packet, it send the packet to bridge 0. The upper layer will send the packet to bridge 0, and the processing code of bridge 0 determines whether the packets will be forwarded to Ethernet 0, Ethernet 1, or both. It will be determined by the processing code of the bridge 0. Similarly, packets received on Ethernet 0 and Ethernet are sent to bridge 0, and the processing code of bridge 0 determines whether to forward the packet, discard the packet, or send the packet to the upper layer network protocol stack. So you can imagine this bridge 0, what is the role of this bridge 0 concept here. This will decide how the packets will move downward and how the packet is going to move upward here. So the network bridge provide the following two key functions. जो हमने अभी bridge 0 की बात की, network bridge जो है, that is in the virtualized environment, that is basically doing two things: MAC learning and packet forwarding. The network bridge learns the MAC addresses. Initially, the network bridge has no mapping between MAC addresses and ports and send data like a hub. However, when sending data, the network bridge learns a MAC address. पहले उसको पता नहीं है. Has no mapping between the MAC address and ports and send data like a hub. वो send करेगा. You know how this hub works. उसको simply एक सबको send करने के तरीके से जो है वो hub जैसे work करती है. It will send in that way. So, however, when sending data, the network bridge learns the MAC address. Sending करने पे उसको पता लगता है ये MAC address है डाटा पैकेट, and find the corresponding ports. उसको MAC address से corresponding ports का पता चलता है. Setting up a mapping between the MAC address and ports came into existence. तो setting up हो जाएगी कि क्या MAC address पे mapping कैसे होगी ports की, कैसी mapping है. तो वो एक तरह की MAC learning जो है वो network bridge जो है वो support कर रहा है. And in case of packet forwarding, it is also doing the functionality of packet forwarding. When sending each data packet, the network bridge obtains its destination MAC address and searches the MAC address port table. जब भी वो पैकेट फॉरवर्ड करेगा, when sending each packet, the network bridge obtain करेगा destination MAC address and searches the MAC address port table and will find the port through which the data will be sent. कहाँ पे वो how this data is going to be sent on that. So in the case of network bridge, two things are happening: MAC learning and packet forwarding is done. We know with virtualization, each VM has a virtual NIC. Network interface क्या है तो हर machine का होगा. And this Linux operating system will generate we can say a tab device in user mode. What is basically a tab device in user mode and a tune tab device driver and NIC driver in kernel mode. Always remember one thing: this tab device is in user mode and tune tab device driver and NIC driver are in the kernel mode. So data sent from a VM address, the VM passes I am allowing this time. Other in the next lecture, I will not allow anybody. People are 20 minutes late. This students are 20 minutes late. Ritvik, how you can try at 10 9:50 से मैंने क्लास ज्वाइन की है. 10 की मीटिंग 9:30 पे ज्वाइन कर लूं. What is this, Ritvik? So we have a tab device in the user mode and tune tab device driver and NIC driver in the kernel mode. Data sent from a virtual machine passes through the tune tab device and the corrected device file in the user mode passes through the tune tab device driver and virtual NIC driver in the kernel mode and is sent to the TCP IP protocol stack. You can see here, I'll show you here. how this is going to work. This is a diagram here. You can see this is a two-tab device driver, NIC driver, virtual NIC driver, and this is virtual machine. And this is TuneTap character device file here, and TuneTap the character device driver here. So, and this is bridge 0, virtual NIC tap is connected, and this is TCP/IP protocol stack. Is there any issue in the class? Ramneet Singh, की problem है? Mind it. If I found anybody talking and disturbing my class, I will remove that person and will not add next time. Because if you are not interested, you may leave the this room, this classroom. So you can see here this VM is how this virtual machine is connected with this bridge 0. This is the diagram representing the information conversion from moving from bridge 0 to virtual machine up to the virtual machine. This bridge 0 is connected with virtual machine, virtual NIC network interface card tag. So, and there you can see this is TCP/IP protocol stack, and this TuneTap virtual NIC driver is connected to this TCP/IP protocol stack. Here again you can see this virtual machine has a TuneTap character device file, and this device file is being managed by a device character device driver.
हेलो हेलो मैम.
हाँ जी जोबनदीप.
मैम वो सर्व को एक्सेप्ट कर लीजिए, सर्व की रिक्वेस्ट वो उसका अनकनेक्टेड हो गया था. मैम सर्व की रिक्वेस्ट एक्सेप्ट कर लीजिए.
You can message me. I'm not able to hear you. You can message me on WhatsApp either or on this chat section. If this is the disabled, you can WhatsApp me here on here. So with this TuneTap, now this Danshu is coming and joining the class. What is happening here? I don't know. And now it's 10:24 here. So this Linux operating system is generated tab device in user mode and to device driver, both NIC and TuneTap device driver in the kernel. Data sent from a virtual machine passes through the TuneTap character device file in the user mode and passes through the TuneTap device driver and the virtual NIC driver in the kernel mode and is sent to the TCP/IP protocol stack and is then forwarded to the virtual NIC tab in the user mode. You can see here virtual NIC tab here. So in this way, this virtual machine is giving the data, and here it is moving in this way from the device file to the device driver and to the NIC TuneTap virtual NIC driver, and here TCP/IP protocol stack. And the tap is now directly connected to the network bridge, and Ethernet 0 and Ethernet 1 in the proceeding figure will act as an NIC tap of the virtual machine. So this NIC tap of the virtual machine, this will work as Ethernet 0 and Ethernet 1 here. So that is the basic concept, how this virtual machine is going to be connected with the bridge 0 and will communicate through the Ethernet port 1 and Ethernet port 0 or any kind of such port for exchanging information over various networks in the in the physical environment. So that is, you can see these things, these virtual TuneTap device file, device driver, and this NIC driver, these everything, this virtualized, that is being created virtualized. Such kind of things are having a file kind of structure and will not have a, we can say, a physical kind of structure. They are in the we can say we can't touch these things. They are in the form of software, on the form of a file for managing the network here. Now the storage basics for cloud computing. We are moving toward the storage basics of cloud computing. Can you hear me? Now we are moving toward the storage basics for cloud computing. We know hard disks are indispensable part of personal computer. We cannot work without these hard disks. And both laptops and desktop computer, everything we deal with the hard disk because for the storage purpose. But this in cloud computing, these are also an indispensable part. ये नहीं है कि we are only concerned with the physical devices और हम physical computer में ही hard disk का issue है. If we are creating a virtualized kind of computer, we are concerned with the hard disk. We are concerned with how we can store the data on those hard disks, how we can access the data we have saved on those hard disks. So that is basically a concern. However, unlike the disk in the common PCs, the disk in the cloud computing are not physical entities. As I am talking, for physical, they are not physical that we can touch. The cloud users concern themselves only with the disk performance and capacity rather than their physical attributes. So whenever we are dealing in the cloud computing environment with the hard disk, we are not concerned with their physical attributes, वो कैसी हैं, how much space they are going to occupy, कितने millimeter maximum कितनी है, and all the such kind of physical concepts. We're talking in terms of disk performance, their capacity, because we are concerned with the basic capacity of that very disk in the virtualized environment. However, as a cloud computing engineer, you need to know only the end user concern, but also how to convert a physical device to a cloud disk. आपके पास एक physical device है. Whenever you are creating a cloud environment, you are dealing with your physical machine, and you cannot use a simple hard disk that is in your PC or the same configuration for creating a virtualized environment. You need to have a very high configuration, whether it's on related to memory, whether it's related to processor, whether it's related to hard disk, so that we are creating a virtualized environment. And if virtualized machines or 4 virtualized machines are being created using a single machine, we can do that easily. uh, because if the space or hard disk is of low capacity, it will not serve the purpose of virtual machine here. That is the basic concept here. So same way, the hard disks are indispensable in case of cloud computing environment. So this is the storage architecture in virtualization, and you can see here this storage architecture in virtualization. This is a no virtualized kind of storage shown here, and there is a single line that is differentiating between the virtualized kind of storage and a non-virtualized kind of storage here. You can see this is a shared catalog here that is having various files with the various kind of, we can say, the extension like VHD hai, VMDK hai. So these are the various file formats, like, and this concept of placing them together, this thing of placing them all together is called a shared catalog. Basically, we can see here VMDK is a virtual machine disk that format for VMware workstation. This is a short form of that very particular kind of file format. These are the file format: virtual hard disk, virtual machine disk, and such kind of disk that are with the uh, share that are there in the shared catalog. So these are the extension of various files or data we have on those disks. So after that, you can see here these are the logical volume, the file system here. The file system is in the form of logical volume, and this file system is connected with this logical division and the file system division here. So there are two kind of approaches for storage in the virtualized environment, and one is called NAS storage, and in the logical division we have a SAN storage. What does this NAS storage and SAN storage mean here is, NAS storage stand for network address system or translation, network attached storage, NAS, and SAN stand for storage attached network. Always remember thing, the NAS is network attached storage. Okay, storage, network attached storage, and this SAN stands for storage area network. So these two are different things. This storage area network shares a shared pool of resources, and storage area network is um, is combined to form a logical volumes that are usually called logical units, LUN 1, 2, 3, or a logical units, and we'll see that later on. And these are the storage. This is basically a storage pool here. You can see this is a storage pool. This is storage pool, and these devices, these hard disk here or array of disk here, they are coming from the various physical devices. जैसे आपकी class, we can say in your class we have various hard disk and we are connecting through a network to create a virtualized environment. We are using 10 pieces from 10 students, and their hard disks are being used for storage in the virtualized environment. So these will form a shared pool of storage pool of those students in the form of disk, and these are being used as a logical division for creating a storage area network. Creating a storage area network. So, Ritvik, have you joined or still Ritvik is not able to join? Don't know what is the issue here that Ritvik, I think, is not able to join. So you can see this storage pool is working two ways, one in the file system mode and in the logical division here. And this file system is called network attached network attached storage, and the storage that is networkly attached. And this is storage area network created for a logical division that is being converted into a file system that is a logical volumes here. But in a non-virtualized, link it with your ID and which is mentioned. Uh, so you can see here in the non-virtualized environment, in the non-virtualized storage, there is a simple system where physical devices are working. Then we have a distributed storage and distributed storage pool from where we are working in the form of we are working in the logical units, and then we have a logical division here. So this is a virtualized kind of storage having different kind of file format and sharing a shared catalog here and a shared storage pool where from where we can see we can access the various disk space. But for the virtualized machines, we are virtual machine will never know from where which physical host that disk is coming from, or the physical location of a particular disk. If a virtual machine is using some space in the form of a disk, the virtual machine will never know this from where this disk is coming. It is coming from a virtualized storage pool. So that is a concept here in the storage architecture in case of virtualization. Uh, Centralized storage means that all the storage sources are centrally deployed and are provisioned over a unified interface. So this is kind of centralized storage. With centralized storage, all physical devices are centrally deployed in disk enclosures and are used to provide storage services externally through the controller. Centralized storage typically refers to disk arrays. Based on the technical architecture, the centralized storage can be categorized as SAN and NAS, that is storage area network and network attached storage. So whenever we talk about storage area network, we have different types of storage area networks here. You can see they are further categorized: FC SAN, FC scan, IP SAN, and FOCOE SAN. So FC SAN, IP SAN are some of the technologies that are being used by various cloud computing service provider like Hawaii, or we can say Azure, Microsoft Azure, or Amazon Web Services. But this FOCE SAN still has a long way to go and is not, we can say, being used maturely. Basically, a disk array combines multiple physical disks into a single logical unit. A disk array combining multiple physical disks into a single logical unit. Each disk array consists of one controller enclosure and multiple disk enclosure. So the array of disk contains a one single controller enclosure and a multiple disk enclosures. The architecture delivers, and that architecture is called SAN. And this architecture delivers an intelligent storage space featuring high availability, high performance, and large capacity. So the devices are, the disk array are connected and they are forming storage area network. And that array of disk has a single, we can say single controller enclosure and multiple disk enclosure. And these area of storage area networks that are connected, storage things are connected by a network, will deliver a high, will have high availability, high performance, and large capacity. Why high availability? Because if the storage space is not available or not working properly, other storage spaces in the shared pool storage area network will be available for performing the compute work, any related to the storage of the data. And such kind of storage area network will definitely have large capacity, will have high performance. So that is a concept here in the case of storage area network. The storage, what is the storage area network? Basically with blocks as basic data access unit. क्या है ये storage area? These are the basic blocks having basic data access unit and is dedicated high speed storage network. It is high speed storage network that is independent of the service network system. So it is basically independent of the basic service network system. Networking as a, this type of network is implemented in the form of fiber channel storage area network, that is called FC, and IP SAN is for internet protocol storage area network. We are not able to log in, ma'am. Who is this? Who is not able to log in here? Everybody in your class has logged in. Or some of the students are pending. 54 students have joined the class. Don't know what is the problem, why you people are not able to join. You are to join with your login ID and password using. Now you cannot join directly. Otherwise, पहले क्या था? We share the link and you can join directly. You can join if you have you are registered with the Zoom. So storage area network with blocks as basic data access unit is a dedicated high-speed storage network, and that is independent of the service network system. This type of network is implemented in the FCCAN. We have discussed this is fiber channel storage area network and IP storage area network and serial attached SCSI storage area network, and that is called SAS-SAN. SAS-SAN. Riksha Bhandari, please tell her that you are late. That is why you are not able to join the class. Different implementation transfer data, commands, and status between servers and storage devices using different communication protocols and connections. So the different kind of implementation, whether it is FC-SAN, IP-SAN, and serial attached SCSI storage area network, they have different kind of transferring of data, command, and status between server and storage devices using different communication protocols and connections. Before SAN, there was a direct attached storage, and that is called DAS. That DAS is the most widely used storage system before SAN is introduced. DAS has been used for nearly 40 years. Purana tha concept, we use direct attached storage. Direct attached storage means like we can directly attach storage and we can use the concept of storage of the various things. And next is DAS has been used for nearly 40 years. Early data center used disk arrays to expand storage capabilities. We know that disk arrays were working. We have a concept of RAID here, redundant array of disk, that was working in case of direct attached storage. Storage devices of each server serve only a single application and provide an isolated storage environment. However, isolated storage environment was being provided using a single application. These isolated storage devices are difficult to share and manage, but those isolated devices are difficult to share and manage. With the increase of user data, the disadvantage of their expansion mode in terms of expansion and disaster recovery are increasing obviously, because with the passage of time data is increasing, and if they are totally isolated and cannot be extended into an expansion mode, and any kind of expansion is not available. So in that case, we cannot manage the concept of disaster recovery. If a disaster happens, we cannot recover our data of so many users that are working on the that are using the cloud. So that chances of losing the data information increase will increase definitely. So SAN ने क्या किया था? SAN the resolve the issues that were that was there with the direct attached storage. SAN connects these isolated storage islands through a high speed network. तो SAN क्या करेगा? They will resolve these issues and connect these isolated storage islands to a high speed network. These storage devices can be shared by multiple servers through the network, delivering remote data backup and excellent scalability. So these storage devices, जो SAN की थी, SAN connects isolated storage islands through a high speed network, इनको combine करा था, and can be shared by multiple servers. These storage devices can be shared by multiple servers through the network, delivering remote data backup and excellent scalability. Because we can extend the storage space, we can increase or scale up and scale down those storage spaces, storage devices. So scalability was excellent. All these factors make this storage technology develop rapidly. As an emerging storage solution, SAN accelerates data transfer. You can maybe ask a question, what is SAN? It will accelerate, and what are the features? It accelerates data transfer, will deliver greater flexibility, and will reduce network complexity. So it will help in the elevating the impact of transfer bottlenecks on the system, that is basically concerned with the physical devices to virtual machines, or from one virtual machine to another virtual machine. Because if scalability is there, the chances of network bottlenecks will be minimum. And who are waiting in the waiting room? Taranjit Singh and Upali Kumari. You cannot join the class, Taranjit. Sorry. Please come on time. So that will elevate the impact of transfer bottlenecks on the system. Usually, we feel that there are network bottlenecks when there is a, we can say, rush of storage spaces, and it will definitely improve the efficiency of the remote disaster recovery mechanism. So we can say direct attached storage was being used widely among the devices, and expansion was possible. Expansion was not possible, so we introduced a concept called storage area network, and that was used in the cloud computing environment. And how this storage area network is helping in the cloud computing environment for achieving better scalability, reducing network complexity, and such concepts are being provided by storage area network. Next is on SAN, all communication related to data storage is implemented on an independent network. We know that they are totally on the independent, that is isolated from the application network. The application network, from that it is totally, SAN is totally independent from that network application, which means that transferring data on a SAN does not affect the data network of the existing application system. Okay. So जो data network existing application system पे है, it will not, SAN will not affect that. Therefore, SAN delivers higher input-output capabilities of the entire network without reducing data network. So, a SAN will have higher input-output capabilities because it is not, it is totally independent from the application network. Efficiency of the original application system without reducing the application. data network efficiency of the original application system. Redundant links to the storage system and support for high availability cluster system. And we know what is high availability cluster system. मैंने last time as a feature in the virtualized environment, I have told you what are the features of the virtualization. In that lecture, I told you regarding this high availability cluster system. So that was about SAN. Now, NAS. This network attached storage is a technology that integrates distributed and independent data into large scale and a centralized data center for access by different hosts and application servers. NAS is a file level computer data storage connected to computer network. So this is basically high level computer data storage connected to computer network, providing data access to heterogeneous group of clients. So data access is being provided to a heterogeneous group of clients. I'll show you the diagram here that how this SAN and NAS differ. You can see we have discussed this SAN storage area network. Now we are discussing this network attached storage, and this is basically a file system concept here that is working. So NAS is a file level computer data storage connected to computer network, providing data access to the heterogeneous group of clients. And NAS server contains storage devices such as disk array, CD, DVD drives, tape drives, portable storage media. So this network attached storage server contains every kind of heterogeneous devices like CD drives, tape drives, portable storage media. Network attached server delivers an embedded operating system share file across platforms. Because why this need a embedded operating system to share file across different platforms. NAS typically has its own nodes on a local area network. Local area network में NAS की अपनी nodes हैं and does not require the intervention of application server at all. NAS allows user to directly access the file data over the network. In this configuration, NAS centrally manages and processes all shared files on the network, and it releases load from application or enterprise server, reducing the total cost of ownership. TCO stands for the reducing the total cost of ownership and maximizing customers' ROI, rate of interest. Simply speaking, NAS is a device that is connected to the network with file storage function. Therefore, NAS is also called network file storage device because it is basically dealing with the simple network file storage. NAS is dedicated file data storage server. It delivers centralized file storage and management and separates storage devices from the servers. So basically concept of NAS is network attached storage is separating the storage devices from server and releasing bandwidth, improving performance, maximizing the customer ROI, and totally reducing the uh, total cost of ownership. So if you are using these things, uh, you have reduced definitely reduce the total cost of ownership. That will be more if you are not using NAS, network attached storage kind of concept for a centralized storage pool for device for in the virtualized environment, for working in the virtualized environment. Because in the virtual machine we need to have a storage space, and we'll see how this NAS can be connected and this SAN will be used for storage. So this is the basic difference between a NAS and a SAN region. The advantage of NAS is that it can deliver file storage devices in a fast and cost-effective manner using existing resources in the data center. So NAS क्या कर रहा है? It can deliver file storage services in a fast and cost-effective manner using existing resources in the data center. The current solution is compatible between Linux, Unix, and Windows operating system. So network attached storage works for the Unix, Linux, and Windows operating system, and can be easily connected to the user TCP/IP networks. The following shows the NAS system here. This is basically a NAS system working on one side Unix like server and on the other Windows server, and in between there is a network attached storage, and you can see this is a window client and this is a Unix client. So this can communicate with each other in the form of network attached storage. So that is possible in the network attached storage. So that was a total concept related to uh, the whole concept related to how virtual in a virtualized environment the various networking and storage devices are working. So that is basically shown here in the diagrams and in the form of other things. Who is this मेरा तो login नहीं हो रहा. So now we are moving towards the next topic, and that is cloud computing architecture. We have discussed and the two models, the service model and deployment models. But how these service models and deployment models are being used by various people at various levels in their SaaS or PaaS, or we can say public, private, or hybrid or community cloud. So we'll discuss that, how these layers are going to work, what are the stakeholders in the cloud computing architecture, or we can say the actors. We'll discuss those things in detail here. So before that, we'll have a quiz here for the previous topic. Who is speaking? Ami Rose? Please don't tell me that due to network issues I was disconnected and all these things. I know who has joined at 10 and 10, 10 and 10, 15, 10, 20, and who is joining right now. मैं मैम देख के ज्वाइन करे तो आके बंद करके थोड़ी बैठे हैं टीचर. So before that we have a quiz here. We'll have quiz here. So I'm launching. You are to answer these questions. What is SAN-NAS? Kindly answer these questions. Answer these questions. The dash with blocks as basic data access unit is a dedicated high-speed storage network that is independent of the service network system, whether it's a storage area network or network attached storage. Next is which type of storage support high availability of the network system. So in which network, NAS or SAN, we have high availability of storage of the network system. Kindly answer these questions. This will mark your attendance. As we mark attendance 4 times in class, we will mark attendance now based on your based on your response to this quiz. Which type of storage support high availability of network system? We have discussed this topic at the last, whether it's a storage area network or network attached storage. So you have to answer both the questions. All are required to answer these questions. Still, some students have not answered these questions. Still, students are pending. Kindly answer these questions. I am ending the poll.
मैम मेरा poll नहीं खुल रहा है,
नहीं चल रहा poll.
poll show नहीं कर रहा है मैम.
It may be due to that you have joined late in the class. Maybe due to that. आपने अभी ज्वाइन किया ना? You have joined 2
नहीं
minutes
मैम,
back.
आधे घंटे हो गए ज्वाइन किए हुए.
Don't know the reason why it is not showing to you, because this is available to everybody. You will see that there are issues that students are saying they are not able to see the poll. We'll talk to the HOD and we'll let you know. Kindly answer these questions. I'm ending the poll. So the SAN with block as data storage area network with blocks as data access unit is a dedicated high-speed storage network that is independent of the service network system. Which type of storage support high availability of the network system? So, which kind of supports the high availability? I have discussed here that this is SAN. So SAN supports the high availability. You can see on the screen here. This is a high availability cluster. It supports the high availability cluster. So answer is SAN. Only 13 students have answered correctly. Both the answers, both the questions, the answer is SAN, storage area network, for the first question as well as for the second question. So high availability support system storage support is being provided by the storage area network. You can see your answers here, what you have answered. Now there is another quiz related to the same topic. You have to answer these questions. Dash is a technology that integrates distributed and independent data into a large scale and centralized data center for access by different host and application servers, whether it's NAS, SAN, or both. And Dash allows users to directly access file data over the network. In this configuration, it centrally manages and processes all shared files on the network and releases loads from application or enterprise server, reducing the TCO, that is total cost of ownership. So ये क्या है, whether it is NAS or SAN or both. Kindly answer these questions. Only 10 students have answered these questions. So whether it's a SAN, NAS, or both, which kind of technology is it that integrate distributed and independent data in a large scale and centralized data center for accessing by different hosts and application servers? So 20 seconds left. I'm ending poll after 20 seconds. Kindly be fast. Answer both the questions. So I'm ending the poll. The first answer to both the question is NAS, network attached storage, is a technology that integrates distributed and independent data into large scale and centralized data center for access by different host and application servers. So the technology is NAS. And another question was which technology allows user to directly access file data over the network. In this configuration, it centrally manages and processes all shared files on the network and releases loads from application or enterprise server, reducing the total cost of ownership. So the answer is NAS, network attached storage. I'm sharing the result here. You can see what you have answered. So in the both cases, the answer is NAS, network attached storage. So this was all about storage area network, network attached storage, and storage devices, how they are working in the virtualized environment. Now next
first
topic is cloud computing architecture. Here in the diagram, you can see a conceptual reference model. Basically, cloud is a conceptual reference model and a high level architecture. Cloud high level architecture is shown to you here. You can see the cloud different people here, like cloud consumer, cloud broker, cloud auditor, and cloud provider here. And you here you can see in the green line here, then green bar here, that is the cloud carrier. So this is the basic architecture of cloud computing that consists of this the reference model consists of various stakeholders, or we can say the actors, the people who are working with the cloud. Like we have cloud consumer, auditor, cloud provider, cloud broker, and cloud carrier. So five major actors with the roles and responsibilities, activities are shown in this diagram, and we will discuss those things in today's lecture. Understanding of the requirement, uses, and characteristics and standards of cloud computing that should be of concern while studying these actors like cloud consumer, provider, broker, auditor, and carrier. You can see here, this gray area, this gray bar represent the provider. So the provider is providing the various services like AaaS, we know infrastructure as a service, the PaaS, platform as a service, and SaaS. And these are the service layer, because on infrastructure, the another layer that is built is a PaaS, and on the PaaS we have built a layer called SaaS, software as a service. No, software as a service cannot exist without AaaS. Cannot exist without AaaS. So that is basic concern here. You are kindly wait for 2-3 minutes and we come back. After that, we will discuss all these things.
Hello.
Hello, hello.
Hello.
Ma'am, unmute.
Vishal, Kumar, Yashwant, is there any issue? You people are talking. So we were discussing the cloud conceptual reference model, and this is a architecture shown here, and we'll discuss all these things. What are the duties, roles, and responsibilities of every stakeholder in the cloud computing environment? So basically, we know what are the basic characteristics of cloud service. On-demand self-service, we have discussed about that. Broad network access is being provided by the cloud architecture. Resource pooling is there. Rapid elasticity is there, and a measured service is also being provided by the cloud computing environment. So these are some of the advantages of the cloud computing architecture, and we have discussed these things in the very first lecture. On demand self service, broad network access होना चाहिए. Resource pooling is the concept, rapid elasticity and measured service. Now, first thing is about the actors. Actors in cloud computing. You can see we have different actors like cloud consumer, provider, auditor, broker, and carrier. Consumer is the person or organization. It may be a person or an organization that maintains a business relationship with the user and uses services from the cloud providers. So the consumer can be, it can be me, myself, or it can be any company related to me. Like I am having any company, I am owning any company. So the cloud consumer may be a person or an organization that is maintaining his or her venture or business relationship on the cloud using services from the cloud provider. A provider is a person or an organization or entity responsible for making the service available to the interested parties. So, cloud auditor, a party. What is cloud auditor? A party that can conduct independent assessment of cloud services. So, auditor is always an independent entity, party, or it may be organization that audit the work of the service provider, like information system operations, performance, and security of the cloud implementation. So the services that are being provided by a service provider is audited by a independent uh, auditor, independent organization, we can say, that checks the system operations, their performance, and security of particular cloud implementation. Cloud broker, an entity that manages the use, performance, and delivery of cloud services and negotiates the relationship between cloud broker is an entity that manages the use, performance, and delivery of cloud services and negotiate relationship between cloud provider and cloud consumer. So broker is a kind of negotiator that negotiate between the cloud provider and the cloud consumer. And next is the cloud carrier. Cloud carrier is basically not an entity, not a kind of person. It is an intermediary that provides connectivity and transport of cloud services from cloud provider to cloud consumer. So cloud carrier is basically, we can say, a technology, or we can say the internet, or any kind of medium that is providing the services of the provider to the consumer. So here in the diagram you can see we have a cloud consumer. Cloud consumer interact with the cloud broker, cloud provider, and can check the information from the cloud auditor. So this cloud auditor is interacting with the cloud provider and cloud consumer. So auditor will audit the various services provided by the provider. And in the same way, the broker is interacting with the auditor, consumer, and the cloud provider. So this is a diagram we presented how these broker, auditor, consumer, and provider are interacting with each other. Now, there are different types of scenarios that clearly explain the concept of cloud architecture as well as active. This scenario one here shown is, you can see cloud consumer interacting with the cloud broker instead of contacting a cloud provider directly. So this is a scenario in which consumer is looking for some kind of cloud services, but this consumer is looking towards a broker to see who is providing which services and at which cost. So the cloud broker will tell you as a consumer whether to take the services of the provider one or the provider two. So the cloud broker may create a new service by combining multiple services or by enhancing the existing service. It is up to the broker that broker will create a mashup of various services by different provided by different people or different organization, and they will provide you a mashup of those facilities or services. So the consumer can have services from various providers. Actual cloud provider are invisible to the cloud consumer. So actually one scenario is that consumer is not able to see the cloud provider. The broker is providing the services from the various cloud providers, and it is acting as a intermediary between the consumer and the provider. Scenario 2, in cloud carrier provide the connectivity and transport of cloud services from the cloud provider. This cloud carrier provides the connectivity and transport of cloud services from cloud provider to cloud consumer. So we have two SLAs can be there. One SLA is called between the cloud consumer and cloud provider, and other SLAs between the cloud carrier and cloud provider. Thus, what does this SLA stand for? Is service level agreement. We'll discuss that topic in detail in the next topic coming lecture, or in this lecture. SLAs are service level agreement that defines what are the various services they are being they are providing to the consumer or to the provider, and it is a kind of contract between the two people or two organization, or people and an organization, for providing various services. SLA 1 is between the cloud consumer and cloud provider, and SLA 2 is between the provider and the cloud carrier. A cloud provider may request cloud carrier to provide dedicated encrypted connections to ensure the cloud services. So if a cloud provider is providing some kind of services, and the provider will see the cloud carrier and will ask the cloud carrier to provide me such services that my service should be encrypted, my connection should be encrypted, because it is basically a carrier. My connection should be encrypted and it will ensure proper delivery to my customer. So if it is providing encrypted kind of service to this provider, the provider whenever issues or provide services to the consumer, it will be encrypted and more secure. So that is the concern here, that is shown here, that service level agreement can be between the cloud carrier and cloud provider, and cloud provider and consumer. But these service level agreements will be totally different, because here if there is more than one consumer here, we can see the consumer here, cloud consumer 1 or cloud consumer 2 here, that SLA will be totally different from the SLA 1 and SLA 2, because that will be totally related to the cloud provider and the consumer. And that is consumer number 2. Now that there is another concept, another scenario here you can see, in which there is one consumer, auditor and provider. Cloud auditor conducts an independent assessment for the operation and security of the cloud services. So you can see in the diagram here, this auditor is conducting independent assessment of the operations and security of the cloud service. The audit may involve interaction with both the cloud consumer and the cloud provider. So any kind of interaction between the consumer and the cloud provider can be possible between the auditor and the consumer. So these three may interact with each other for auditing. Consumer can see the audit report of the provider, and provider can also see the report, or can also see the report of the auditor. Provider can also see the report of the auditor. So this is the basic concept here. Next is cloud consumer. So the cloud consumer and browses this cloud consumer. What is cloud consumer? What can do the cloud consumer? Cloud consumer browses and uses the services, sets up contract with cloud provider. Cloud consumers need SLAs to specify the technical performance requirement fulfilled by a cloud provider. SLAs cover the quality of service, securities, Remedies for performance failures. A cloud provider lists some SLAs that limit and obligate the cloud consumer by must acceptance. So these are the duties of the cloud consumer. You can see cloud consumer browses and uses the services. Cloud consumer setups contract with the cloud provider. Cloud consumer needs SLAs to specify the technical performance requirements fulfilled by a cloud provider. SLAs cover the quality of service, securities, remedies of performance failures. A cloud provider lists some SLAs that limit and obligate the cloud consumer by must acceptance. Cloud consumer can freely choose a cloud provider with better pricing with favorable conditions. Pricing policies and SLAs are non-negotiable. So you can see this diagram. This is diagram is about the cloud consumer, and cloud consumer is using these various services like ERP, billing, sales, CRM, collaboration, document management, email and office productivity, content management, financial, social networks, and human resources. You can see here the business intelligence, databases, application deployment, integration, development, and testing. And here you can see the storage, service management, platform hosting, compute, backup and recovery. These are all related to IaaS consumer. These are related to PaaS consumer, and these are related to SaaS consumer. So these are the services that are being used by consumers. If you as a consumer want to take the services, you have to see whether want to take the services of the IaaS consumer, PaaS consumer, or SaaS consumer. It may be ERP, billing, sales, CRM, collaboration, document management, email and office productivity, content management, financial, social networks, human resources. Or it can be a database, application deployment, business intelligence, development and testing, integration. So here IaaS, you can see compute, platform hosting, service management, storage, CDN, backup and recovery. So these are the consumer services. SaaS consumer. SaaS consumer can be organization that provide their members with the access to software application and user who directly use software applications, or software application administrator who configure application for end user. SaaS consumer can be built based on the number of end user, the time of use, the network bandwidth consumed, and the amount of data stored, duration of the stored data. So that is the basic concept in the case of SaaS consumer. PaaS consumer. The PaaS consumer can be application developers or administrators who design and implement application software, application testers, or who run the test applications, who publish application into the cloud, or who configure and monitor applications performance. So these are the things. PaaS consumer can design and implement application software, application testers who run and test applications, who can publish into the cloud, who can configure and monitor application performance. PaaS consumer can be built according to processing, database storage, and network resources consumed by the PaaS application and the duration of the platform's usage. IaaS consumer. IaaS consumer can be system developers, system administrators, and IT managers who are interested in creating, installing, managing, and monitoring service for IT infrastructure. So IaaS consumer basically deals with the IT infrastructure of creating, installing, managing, and monitoring services for IT infrastructure operations. IaaS consumer can be built according to the amount or duration of the resources consumed, such as CPU hours used by the virtual computer, volume and duration of data stored, network bandwidth consumed, number of IP addresses used for certain intervals. So that is the basic concept here. Now next is the cloud provider. Cloud provider acquires and manages the computing infrastructure required for providing the services. Runs the cloud software that provides the services. So cloud provider is providing the services. and makes arrangement to deliver the cloud services to the cloud consumer through network access. SaaS provider deploys, configures, maintains, and updates the operation of the software application on cloud infrastructure. So basically, SaaS provider maintains the expected service level to the cloud consumer. PaaS provider manages the computing infrastructure for the platform and components. IaaS cloud provider provides physical hardware and cloud software that makes the provisioning of these infrastructure services. For example, the physical server, network equipment, storage devices, host operating system, and hypervisor for virtualization. Cloud provider. Five major activities of the cloud provider are service deployment, service orchestration, cloud service management, security, and privacy. So you can see here in the diagram here, the cloud provider is providing service deployment. It will provide the services. Service orchestration means if there is an issue related to managing or increasing or decreasing of any kind of service, that is under service orchestration. So cloud service management, the managing everything related to the cloud. And other thing that is cloud is providing the security, that is also being provided. And with the security, the cloud provider is providing the privacy related to that. Now the cloud auditor. Audits are performed to verify conformance to standards. Auditor evaluates the security controls, privacy impact, performances, etc. Auditing is especially important for federal agencies. Security auditing can make assessment of the security controls to determine the extent to which the controls are implemented correctly, operating as intended, and producing the desired outcome. This is done by verification of the compliance with the regulation and security policy. So the auditors are performing audits, verifying conformance to standards. Auditor evaluates the security controls, privacy impact, performance, etc. Auditing is especially important for federal agencies. Security auditing can make an assessment of the security control to determine the extent to which the controls are implemented correctly, operating as intended, and producing the desired outcome. This is done by verification of the compliance with the regulation and security policy. So you can imagine it is everything with the auditor for evaluating the security controls, providing privacy impact and performance. Auditing is especially important for federal agencies. Security auditing can make assessment of the security control to determine the extent to which the controls are implemented correctly, operating as intended, producing desired outcome. This is done by verification of the compliance with regulation and security policy. Privacy audits helps in federal agencies comply with the applicable privacy laws and regulations, governing an individual privacy to ensure confidentiality, integrity, and availability of the individual's personal information at every stage of development and operation. Next is the cloud broker. Integration of the cloud services can be complex for consumer. Hence, cloud broker is needed. Broker manages the use, performance, and delivery of cloud services and negotiate a relationship between the cloud provider and cloud consumer. In general, cloud broker can provide services in three categories. We'll study this cloud broker in detail. Before that, we'll have a we can say a poll here, quiz here, and I'm sharing. I'll have this quiz later on because this is related to this topic. We discuss that integration of cloud services can be complex for consumer. So hence cloud broker is needed. Broker manages the use, performance, and delivery of cloud services and negotiate relationship between the cloud provider and cloud consumer. In general, a cloud broker can provide services in three categories: service intermediation, service aggregation, and service arbitrage. So in the service intermediation, what is service intermediation? Broker enhances a service by improving the capability and providing value added services to the customer. The improvement can be managing access to cloud services, identity management, performance reporting, enhanced security, etc. Service aggregation. Broker combines and integrates multiple services into one or more new services. The broker provides data integration and ensures the secure data movement. Service arbitration. It is similar to service aggregation with the flexibility to choose services from multiple agencies. For example, broker can select the service best response time. So a broker provide the following services as I have discussed: service intermediation, enhancing the service by improving capability and providing value added service to consumers. This value added service may be cloud identity management, performance reporting, enhanced security. And service aggregation, combining various services into a single form. Broker provide data integration and ensures that stored data movement. Service arbitrage. It is similar to service aggregation with the flexibility to choose services from multiple agencies. For example, broker can select service from the best response time. Cloud carrier. Cloud carrier provide access to consumer through network telecommunication and other access devices. For example, cloud consumer can obtain cloud services through network access devices such as customer customer laptop computers, laptops, mobile phones, mobile internet devices. The distribution of cloud services is normally provided by network and telecommunication carriers on a transport agent. Whereas a transport agent refers to business organization that provide physical transport of storage media such as high capacity hard drives. Cloud provider can set up service level agreements with the cloud carrier to provide service consistent with the level of service level agreements offered to the cloud consumer. So cloud carrier provide access to consumer through network, telecommunication and other devices, access devices. Access devices like network access devices includes computers, laptops, mobile phones and mobile internet devices. Distribution of cloud services is normally provided by network and telecommunication carriers or transport agents, where a transport agent refers to business organization that provide physical transport of storage media such as high capacity hard drives. Cloud provider can set up SLAs with the cloud carrier to provide services consistent with the level of SLA offered to cloud consumer. So this was related to cloud carrier. We'll have a quiz here. I'm launching this quiz. You are to answer these questions. Kindly answer these questions. So kindly answer these questions. A person or organization that maintains a business relationship with user services from dash. Kindly answer these questions. All are required to answer these questions. Dash, a person or organization that maintains a business relationship with and uses services from dash cloud broker or cloud service provider. A party that can conduct independent assessment of cloud services, information system operation, performance and security of the cloud implementation. So independent assessment कौन करता है, whether it is a cloud editor or a broker, that is basically the answer between the two. I hope everybody is done with these questions. I am ending the poll here. So to answer to the first question is cloud service provider, and answer to the second question is a cloud auditor, a party that can conduct independent assessment of cloud services, information system operation, performance and security of the cloud implementation. So these are the answers that you have answered here. You can see your result. Now next is scope and control between provider and consumer. Application layer are used by SaaS consumer or installed managed by PaaS consumer. IaaS and SaaS providers, basically applications layers are used by the SaaS consumer or installed managed maintained by PaaS consumer. IaaS consumer and SaaS providers, and basically used by IaaS consumer and SaaS providers. Middleware used by this middleware layer is used by PaaS consumer, installed, managed and maintained by IaaS consumer or PaaS provider. Middleware is hidden from SaaS consumer. IaaS layer is hidden from SaaS consumer and PaaS consumer. Consumer have freedom to choose operating system to be hosted. So IaaS layer is hidden from SaaS consumer and PaaS consumer. Consumer have freedom to choose operating system, but we operating to be choose operating system to be hosted. So IaaS layer is hidden from the SaaS. You can see this IaaS layer is hidden from the SaaS consumer and PaaS consumer. Consumer have freedom. This is a cloud consumer. This is a cloud provider. So the consumer work in this way and the provider work in this way. So consumer work from application layer towards the operating system layer, while the provider work from the operating system layer towards the application layer. So in this scenario, who can control what things is described here? As IaaS layer is hidden from SaaS consumer. This IaaS layer is hidden from the SaaS consumer and PaaS consumer. This PaaS consumer, IaaS consumer, uh, this cannot see this IaaS layer, SaaS and PaaS. This SaaS and PaaS. Consumer have freedom to choose operating system to be hosted. So consumer have the freedom to choose operating system. So आप कौन सा whichever operating system you want to use for hosting your work. Now the question is various kinds of cloud computing architecture that are available. So there are different architectures that are provided by various companies: Web 2.0, Meshup, RSS feed, Hadoop, HDFS, Tom, various Google architectures, Eucalyptus, and Ruby on Rails. So these are the things, these are the architecture, cloud computing architectures that are provided to the consumer based on their requirement, and that are provided by the various companies or organizations that are providing these architecture. Now we are moving towards the service level agreement. What is a service level agreement or SLA? SLA is a bond for performance negotiated between the cloud service provider and the client. Earlier in cloud computing, all service level agreements were negotiated between a client and a service consumer. But nowadays, with the initiation of large utility like cloud computing providers, most service level agreements are standardized until a client becomes a large consumer of cloud services. Service level agreements are also defined at different levels, which are mentioned below. So you can see customer based service level agreement, service based service level agreement, multi-level service level agreements. Few service level agreements are enforceable as contracts, but mostly are agreements or contracts which are more along the lines of an operating level agreement. They are more towards operating level agreement and may not have the restriction of law. It is fine to have an attorney review the document before making a major agreement to the cloud service provider. So it is fine to have an attorney review of the document before making a major agreement to the cloud service provider. Service level agreement usually specifies some parameters which are mentioned below. Availability of the service. It should have, service level agreement should have availability of the service, latency or response time, service components reliability, each party accountability, and warranties. So these are the availability of the service, latency of the response time, service component reliability, each party accountability, warranties. So this is, you can see in the diagram here, this is a life cycle: template definition, negotiation, provisioning, monitoring, enforcement, and expiration. So SLA life cycle is from template definition towards expiration. First a template is being created, then it is basically negotiated. That service level agreement is provisioned for various services. After that, it is checked for monitoring and enforcement. If people are not monitoring that service level agreement, they are enforced to maintain that agreement. And after that, after the services are taken away back, that is called expiration. So templates are defined according to available services that are there. Customer selects a SLA template. Customer selects a template and customer negotiate SLA using a SLA template. Provision means providing service execution, assessment, and corrective action during execution should be in the case of monitoring and enforcement. Next is termination and decommission of the service. So these are the things that are being provided by the we can say that these are the phases in the life cycle here. So below are two major service level agreements described here. So these two agreements are provided by various organizations. Windows Azure SLA, and another one is SQL Azure SLA. So Windows Azure has different SLAs for compute and storage. So there are different types of service level agreement, whether you are going for compute services, whether you are taking compute services, or you are just taking the storage services. For compute, there is a guarantee that when a client deploys two or more role instances in a separate fault and upgrade domains, client internet facing roles will have external connectivity minimum 99.95% of the time. Moreover, all of the role instances of the client are monitored and there is guarantee of detection. 99% of the time when a role instances process is not runs and initiate properly, that is basically the case when this agreement come into picture. Moreover, all the roles of instances of the client and are monitored and there is guarantee of detection. 99% of detection of guarantee of detection is and 99% guarantee is that it will be get detected on time and a role instance process is not running and initiate it properly. Next is SQL Azure SLAs. SQL Azure clients will have connectivity between the database and internet gateway of SQL Azure. So SQL Azure will handle a monthly availability of 99.9% within a month. Monthly availability proportion for a particular tenant database is the ratio of the time the database was available to the customer to the total time in a month. Time is measured in some intervals of minutes in a 30-day monthly cycle. Availability is always remunerated for a complete month. A portion of time is marked as unavailable if the customer attempt to connect to a database are denied by SQL Azure Gateway. So this way you can see if you are taking a single service of such kind, this also matters that this is called SQL Azure SLA. This is one of the uh, service level agreement shown between the database and internet gateway of SQL Azure here. So this was all about the service level agreement. Before that, there is one poll that is left. We'll discuss that poll and we'll discuss the answers of those of that poll. I'm launching here. Kindly answer these questions. still some students are pending. Kindly answer these questions. Cloud consumer need to specify the technical performance requirements fulfilled by a cloud provider, whether it is a SLA or cloud auditor. And other is Dash acquires and manages the computing infrastructure required for providing the services. Runs a cloud software that provides the services and makes arrangement to deliver cloud services to cloud consumer through network access. So this was you have to answer both the questions. So I'm ending poll. Answer to the first question is cloud consumer need to specify the technical dash to specify it needs SLAs. SLA to specify the technical performance required by requirement fulfilled by cloud provider. Next is dash acquires and manages the computing infrastructure required by providing the services. Runs the cloud software that provides the service and makes the arrangement to deliver the cloud services to the cloud consumer through network access. So the answer is cloud providers. You can check your answers here. But you people have answered. So answer to both the question is one first is SLA, the service level agreement, and cloud provider. So this was today's lecture all about what is basically how the SLA works, what is SLA, how these SLA work, what are the various types of SLA. A customer can have SLA service based on multi-level SLAs. But the life cycle of SLA and made two major SLAs shown to you. The Windows Azure SLAs, both of these are from the Windows Azure SLAs. And we discussed today the audit these actors as well as the architecture here. And network attached storage area network and storage architecture in virtualization, And Mac learning was explained, packet forwarding, all these related terms related to the virtual network basics of cloud computing, we can say. With this, our virtualization topic is complete. With this, more clouds architecture topic is complete, cloud reference model, and this how this reference model works, what are the actors and various layers in the cloud architecture. SLS. In the next lecture, we'll talk about other more important topics and we'll talk about in detail about the multi-tenancy concept that is there in the cloud computing. And apart from that, multi-tenancy will also discuss the application programming interfaces that is required in the cloud computing, that is APIs. So with in the coming lecture, we are covering, will be at the half of our syllabus. We can say the half of the syllabus will be completed next time. And after that, that syllabus that is left is related to cloud security, encryption, decryption techniques in the security, cloud forensic terms, and various cloud um, um, case studies like IBM Cloud, Google Cloud, Azure, and how we can take those services. What are the security parameters in those things? We'll talk about the protocols and we'll talk about identity management concept and how we can have identity management, how it is being used, and what are the various versions of identity management. These things we will discuss in part 3 and part 4. Part 1 and part 2 will be completed in next lecture, in the next lecture. So this was all about Jobbanjeet Singh. So I am ending the lecture here.